Hello everyone. In this lesson I'd like to begin looking at how we divide radical expressions. Now consider the square root of a fraction. If I have the square root of 4/9, you remember that I can think of that square root as an exponent. That would be the 1/2 power. And then by my rules of exponents I can distribute that exponent to both the numerator and the denominator. So it makes sense that the square root of 4/9 would just be the square root of 4 divided by the square root of 9, right? 4 to the 1/2 over 9 to the 1/2. So you don't have to think about the fraction I multiply together to get 4/9. You can just think about the number I multiply together to get 4, which is 2, and the number I multiply by itself to get 9, which is 3, and 2 over 3 will be the square root of 4/9, and that'll work for any root. So the nth root of a fraction is just the nth root of the numerator divided by the nth root of the denominator. So if I would like to know the cube root of 343 thousandths, that looks like a pretty nasty fraction, but I can simplify it and just find the cube root of 343 and then divide that by the cube root of 1,000. Now in my calculator here, the cube root of 343, let's see if I go into the math menu here, here's my cube root button, number 4, and the cube root of 343 is 7. Okay? And the cube root of 1,000, that's 10. That's 10 times 10 times 10, that gives you 1,000, so the cube root of 1,000 is 10. Alright, so same thing. If I had the square root of 121 over x squared, I could just write that as the square root of 121 over the square root of x squared. So that would give me 11 on the top, and x, well, not quite. Remember, we have to put absolute values around that because the square root of x squared is actually going to be the absolute value of x. If x was like, say, -2 down here that I started with, if I square -2, I get a +4. Then when I take the square root, I'm not going to get -2, right? I'll get the +2, so I have to put absolute values around that. Okay. Now we can also use the rule in reverse to help us simplify one radical divided by another radical. For example, in this case, I could just put those all together under one radical. And now that I have the fraction under the radical, then I could just cancel the y's and cancel the 4 into the 28. And I would just get that this equals the square root of 7. Okay? Or likewise over here, even if it's a cube root, I could just put this together under a single radical, the cube root of 189 x to the 5th y to the 7th over 7x squared y squared. And we could cancel. I think 7 goes into 189. 7 goes into 18 2 times with 4 left over. And then into 49 7 times. And then x squared goes into x to the 5th x cubed times. And y squared will cancel with y to the 7th, leaving me y to the 5th. So this is the same thing as the cube root. Everything in the denominator is now gone. I'll get 27 x cubed. And I've got a y to the 5th. Let's go ahead and write that as y cubed times y squared. And then I can go ahead and simplify this one step further. The cube root of 27 is 3. Cube root of x cubed is x. Cube root of y cubed is y. And then the y squared is left inside the radical. I'll leave that as the cube root of y squared. So that would be my answer.